video is regarding the basic operation that can be performed on a signal. Suppose we have a signal which is something like, it can be given as f of t is equal to 1 for time less than 1 and greater than minus 1, and it is equal to 0 otherwise. What we should notice in this signal is, it is a signal that is occupying two time units, one time unit here and one time unit here, and has an amplitude of 1 throughout this duration. Now when I am processing this signal, it could happen that I want a signal that occupies only half the time duration and has got the same amplitude. That means a signal which is like this, going from minus 1 by 2 to 1 by 2 on the time axis and has an amplitude 1. Or it can also happen that I want a signal that occupies 4 time duration. So it could be a signal which is like this, going from minus 2 to 2 on the time axis and has an amplitude 1. Now it is possible for me to modify this signal into these types of signal by applying certain operations onto this signal, and those operations are then called as scaling operations. And since we are performing the scaling operation on the time axis, therefore these operations are called as time scaling operations. Now many a times it can also happen that I may desire a signal of the same duration and same amplitude, but here the signal is going from minus 1 to 1. I would want the same kind of a signal occupying the same time duration, that means 2 units of time, from 1 to 3, like this. Or I would want the same kind of a signal but from minus 1 to minus 3, which would look something like this. So to achieve this, what am I doing is, I am shifting the signal on the time axis. For example, here I have shifted the signal to the right, and in this case I have shifted the signal to the left. And since the operations are being done on the time axis, therefore they are called as time shifting operations. Now let us look at all these operations that we can perform on a signal in detail. I will demonstrate the basic operations considering this signal only. When I have written the second equation, what I have done is, I have just not substituted, or I have just not taken the t here. So these equations are without the t component. The first operation on this signal could be when this t changes to t. So now the function that we'll have will be f 2t. Let's now look at how this would modify the signal shape. So at both these places where I had t, now I'll substitute it with 2t, and it will be then written as, so what I have done is, at the place where we had t, I have written 2t. So this is 2t here and this is 2t here. The same function can be written by taking this 2 into the denominator of this minus 1 into the denominator of this 1. So it will be then, so what change we'll be seeing in the waveform of this signal will be, it will be going only from minus 1 by 2 to 1 by 2. So the waveform that we'll get will be, it will be like this. The next operation could be when the same function t changes to 1 by 2t. Here what we'll do is, we'll again modify this equation with this 1 by 2t. So it will be then f 1 by 2t will be equal to, this equation can further be modified by multiplying this 2 with these 1s. So it will be then, the resultant signal that we'll be getting now will range from minus 2 to 2 this is function f1 by 2t, which has an amplitude 1 from -2 to 2. So what do we observe here? When t is changing to 2t, the signal is getting compressed in the time domain, because earlier it was from -1 to 1, now it is from -1 by 2 to 1 by 2. When t is changing to 1 by 2t, the signal is expanding in the time domain, because here now it is going from -2 to 2. This operation can be summarized as, where in f of t, if t is changing to at, where a is multiplied with t and a is some positive integer, the resultant function that we will be getting will be f(at). In this case, if a is greater than 1, it will lead to the compression of the signal in the time domain. So this you can see here. If a is less than 1, it will lead to expansion of the signal in time domain. This you can see here. And these operations are called as time scaling operations. So this is time scaling. Let us now look at the next set of operations with the same signal. So the first operation could be when t is changing to t minus 2. So the function will be f t minus 2, and it will be written as, so at the place where I had t, now I have substituted it as t minus 2. What we can further do is, we can take this minus 2 on these sides, then it will become plus 2, and here also it will be plus 2. So then f of t minus 2 will be equal to 1. What we see here is, now the time has changed and it has changed to 1, 2, 3. So the waveform will now be from time 1 to 3. So now ft minus 2 is a signal that is from 1 to 3 and has an amplitude 1, same as this signal. The other operation on this signal could be when t changes to t plus 3. So the signal that we will now have will be ft plus 3. So it is ft plus 3, and it will be further written as, I have changed it to t plus 3. T plus 3 here and t plus 3 here. This can be further written as, taking this plus 3 on both these sides, then it will become minus 3. So it will be, again the signal has now shifted from minus 2 to minus 4. Earlier it was from minus 1 to 1. Has shifted from minus 2 to minus 4, occupying the same time duration as this signal. When we are applying this operation, what we are achieving is a signal that is shifted to the right, and this shift to the right is called as time delay. When we are doing this operation, we are getting a signal that is shifted. This signal is then shifted to the left, and this is then called as time advance. The complete process that we have done so far can be summarized as, when we are changing the signal from f of t to f of t minus t naught, then it is leading to right shift of the signal, and this is called as delay in the time axis. When we are changing the signal from f of t to f of t plus t naught, which is like this is leading to the left shift of the signal, and the left shift of the signal is called as time advancing of the signal. These operations lead to shifting of the signal in the time domain. Therefore, they are called as time shifting operations. operation that can be performed on a signal, and that is the time reversal operation. The signal that I consider for showing you this kind of an operation is here. Ft is a signal that has got a value 1 from -1 to 2, and the value is 0 other than this duration. When you apply time reversal operation, what happens is t is changed to -t. So f of t will then become f of minus c. So at the place of t, we'll substitute minus t. So here I have substituted minus t at the place of t. Let's now look at how this negative sign would affect these values. So when I take this negative sign on this side and on this side, these signs will also change. F of minus t will now be 1 for the time duration -2 to 1. So the signal will now look like this. When we are applying time reversal, that means when we are changing t to minus t, this is how the signal shape is changing. It can also be observed that when you are applying time reversal, the signal is getting rotated by 180 degrees. So this signal has got rotated by 180 degrees. Or the other way of seeing it as, if you consider this y-axis to be a mirror image is formed when you apply time reversal operation.